Okay, in this tutorial we're going to have a look at functions and relations and a little bit more around our terminology. So our relation is a set of ordered pairs of x and y values. So e.g. 1, 3, 4, 7, 8, 11, 1, 5. So this is an x value, that's y value. Okay? X value, y value, x value, y value, etc. Okay? Functions are sets of ordered pairs in which each x value has a unique y value. Okay, so each of our x values has a unique y value. So you can see this is a relation because 1 has a corresponding y value of 3 and 5. Okay, so this is why this would be a relation. When functions are graphed, a vertical line, okay, can be drawn on the graph and will only cross the graph once, no matter where you draw it. Okay, and this is called the vertical line test. Okay, so if we have a look here, right, we've got our different types of relations. Okay, so we've got a one-to-one, a many-to-one, a one-to-many, and a many-to-many. So this means here, this one, for each individual x value, we get corresponding y value. Okay, here we can get multiple x values giving the same y value. So this x value would give this y value, this x value would give this same y value, and this x value would give this same y value. Okay, that's why it's many x to one y. This one is one x value giving many y values. So for example here, this x value will give a y value here and a y value there. Okay, this many to many is a circle, okay, because many, like this x value will give the same y value, different y values here. Okay, so we get two different y values for our one x value. Similarly, we can get the same y value for two different x values. Now if we look at our vertical line, that means I can draw a vertical line on this one. Okay, and it doesn't matter where I draw it. Okay, I'm only going to cross the graph once, so that's going to be a function. Same with this. Okay, doesn't matter where I draw my vertical line, I'm only going to cross the graph once, so that would also be a function. But you can see here, I could draw a line right at the end here and only cross it once. Okay, but that's not good enough because I need to be able to draw it anywhere. Okay, I can't draw it there, I'm going to cross twice. So that's not a function, and same with this one, also not a function. Okay, so that's the difference between our functions and our relations. Now, I've got a little bit more to talk about with this section. Okay. So, domain and range. So the domain is all the x values of our ordered pairs, or all the x values allowed by our rule. Okay, that's where our domain is. And our range is all the y values for our ordered pairs, all the y values allowed by our rule. Okay, if we look at some function notation, and I'll go into this a little bit more as we keep working through. Okay, this is what a function notation looks like. We have, in this case, f at the start, and this is the letter being used to define our rule. Now that could be anything. That could be G, H. Okay, often it'll be f though. Okay, then we always do two dots there, and then our first one here is our domain. This value here is our domain. Okay, the arrow signifies what we call a mapping, or pairing our x values to our y values. Okay, now this one here, you might think that it makes sense that that's the range. Okay, but it's actually what we call a codomain. So this is the set of all allowable values, but not the allowable y value, but not the range. Okay, so this is, if you like, any restrictions to our y values that we're going to impose that aren't imposed by our function anyway. Okay, and then this is our function ourselves, whatever this is. So for example, to get your head around this codomain idea, we had a quadratic like that. Okay. Well, we could simply have our domain here of all real numbers, and I'll get onto these letters and what they mean in a little bit, but that basically means we can have any x values we like. Okay, so I can go out this way as much as we like. Now we would still probably map that to all real values. So we're not restricting any values for our y. We can use whatever ones we like. Okay, but we can see here that by the very nature of our quadratic, our range is going to be values from 0 up. Okay, so even though we're not restricting this, any y values, our function itself will restrict the y values, which will then give us our range. Okay, so our codomain is just any extra restrictions we want to make. Okay, in the scope of the methods course, you'll never see anything other than R there. Okay, that's a great thing about this, is it will always be R for what you see. Right, so now when we have a look at our parentheses, brackets and braces. Okay, parentheses, now I will almost always just call them round brackets in all my videos. A lot of people do, but they're actually called parentheses. Okay, these can be used to define a single point, e.g. the point 13, but they can also be used to define a range of values where the value itself is not included. So this is a range of values, so all our numbers between 2 and 8, and now that includes all our decimals, fractions, everything between 2 and 8, but we would not include the values 2 or 8. Okay, so we could have 2.000001, okay, as many zeros as you like in between your 2 and your next decimal, okay, all the way up to everything as close to 8 as you can get, but not 8. Okay. Now brackets, these are our square ones, and we often call them square brackets. I think I'll basically always call them square brackets. And they're used to define a range of values where the value itself is included. So here, we've got the range of values from 3 to 5, so everything in between 3 and 5, including 3 or 5. Right, now these can also be used together, so we could have a range of values that was from, say, 2 to 7, right, where we're not including the 2, including anything between the 2 and up to and including the 7. Okay, so we can use them when we're looking at ranges of values, okay, together. If we're just defining a single point though, it's got to be our round ones here. So this one is going to define an x and a y value, as opposed to what we call our braces. Okay, a lot of people kind of call them squiggly looking brackets as well, but they're used to define a list of individual values. So e.g. The individual points 1, 3 and 7. Now these can't be used with our parentheses and brackets or our round and square brackets. Okay, so just be mindful of that. Okay, we've got a little bit more terminology that we'll hit as well. Okay, not much to go now. Okay, so our other terminology, okay, is union. Okay, easy to remember because it looks like a U but it doesn't have our line on the side, and that means to join or include two sets of value. Okay, so e.g. our values are between 1 and 3, okay, and 5 and 7. And you see I've used round brackets here, so I'm not including the points 1, 3, 5 or 7, just the values in between them. Okay, intersection means to use only the values that are the same in two sets of numbers. So e.g. What I've got here from 1 to 7, including 1, not including 7, and the intersection of 4 to 9, including 4, not including 9, we're looking at intersection. Well, intersection between those two would be from 4 up until 7. Okay, that would be the intersection between those two ones. Okay, we also use including as a forward stroke and excluding as a backstroke, and that's usually specific specified values. It can be a range of values, it doesn't have to just be individual values. But for example here, I've got the range of values from 1 until 8, inclusive of both values, excluding 2. Okay, so I'm not going to include 2 there. Hey, getting back to what these R's were before, so R means a set of all real numbers. So that's from negative infinity up until infinity, all our decimals, fractions, everything like that. Okay. If you happen to be doing specialist maths as well, okay, R doesn't include our complex or imaginary numbers. Okay, so R plus means a set of all real positive numbers, not including 0. Okay, don't include 0, which is sometimes a little bit annoying because often we'll want to go from, say, 0 to infinity. Okay, R with a little negative up the top means that all the set of real negative numbers, not including 0. Okay, so if we bring a lot of these ideas together back to our functional notation, we can see here we've got, in our first example, we've got f defining our function. Our domain here is all real positive numbers, including 0. Okay. Now another way you could write this, and often you can write it in multiple different ways. Okay, we're including 0 now, so we could represent that as a square bracket 0. And because it's going up, all real positive ones up in front of that, we could also go up into infinity. And infinity has to have a round bracket, can't have a square bracket. Okay, to R. Okay, so that's our codomain. As I said, we're never going to say anything different really, except I did forget in this one, of f of x equals x squared. So that's our actual function. Here, okay, I've got a little bit forgetful here. I forgot to put in our codomain. For this one, we've got f, again, is defining our function. Now, our domain here, right, is defined as the values between 1 and 5, not including 1, including 5, and the values between 11 and 13, not including 11, but including 13. Our codomain would still be R. Right, as I said, we're never going to see anything different in the scope of methods course. And our function this time is f of x equals 2x take 1. Okay. So this tutorial is really focused on a lot of the terminology that you're going to see, and they'll be throughout the whole entire course. So it's something that's easy to get lost in when you're first starting, but it's something you really need to get your head around to make sure that it doesn't hold you up later on.